All right, this is section 8.2, families and periods of the periodic table. Note as we go through here, there's going to be a couple items that I'm going to want you to put on the outline very specifically, so make sure that you listen for those. Be a couple things that I want you to do that aren't just fill in the blanks. All right, here's the objectives. First of all, in this lesson, section 8.2, we want to be able to identify the groups that are on the periodic table and talk about valence electrons for each one of those. And then talk about the relationship between behavior of the families and their configurations. And then we're going to get into periods, and last be similarities among elements in the same period in the periodic table. Okay, so we've talked a little bit about Mendeleev before, but he put the elements in positions based on their chemical behaviors. In other words, kind of like what compounds did they form. So if we were talking about like group 1A, lithium, sodium, potassium, and so on, they tend to form compounds with chlorine in a 1-to-1 ratio. And all of them tend to do that, form those similar compounds. They're all very reactive. So he said he took those and grouped them together based on their properties. Together, those vertical columns we call families. Sometimes they're also called groups. Okay, so groups or families, either one of those, we're talking about the same thing. We're talking about the ones that go up and down, the vertical ones. On the periodic table that we have today, the modern periodic table, there are a couple different versions as far as some of the conventions, some of the numbering that we have. There's the older convention where things were labeled with the numbers and then A's and B's. And if you can see this, it's kind of a little blurry, but like this would have been 1A, group 2, 2A, and then we would skip all these. These are all B's. If you can't see that, these guys right in here, those are B's. Then this would be 3A through 8A is what those are. And this is the older convention. Then the newer one is that you just number everything. Hey, 1, 2, 3, 4, all the way across to 18. The newer one is simple, obviously, 1 through 18, but it doesn't tell us as much. It's not as useful for us. So we'll actually usually use the older convention. Kind of gives us a little bit more information about things, especially when we're working on forming compounds and so on. It'd be better. Okay, so the newer one's 1 through 18. All right, so let's talk about these different groups. Take a look at the configurations here. And so notice that for lithium, it's 1s2, 2s1. Lithium ends in 2s1. If we talk about sodium, 1s2, 2s2, 2p6, 3s1. And so on. The potassium ends in 4s1. And rubidium in 5s1. And this is the key thing. All of these have one electron in that s sublevel, one valence electron. And this is a relatively unstable arrangement. So these are very reactive metals because of that. So they're always trying to get rid of that electron. They're trying to share it or give it away to another atom because it makes them more stable. And it gives them very similar properties. They're all really reactive. If you take any of these things and put them in water, they will react violently. Take sodium, put it in water, and it'll start to burn. You take things like cesium and put it in water, and it'll explode. The group 2A elements are known as the alkaline earth elements, and you can see if you look at their configurations that they have a 2S or an S2 in all of those. So if you look at, the shortcuts are always good ones because they just show you the valence electrons, and you can see 2s2, 3s2, 4s2. So all of these have 2 valence electrons. That puts them in 2A. Okay, so all of the S, keep track of the fact that all the S and P's, these are our group A elements. Okay. Now we filled up the S, so if you keep on going now, you start to see that we're starting to fill the P. So here's group 3A, 2s2, 2p1. Group 3A doesn't really have a special name. In the new convention, it's group 13, but no special name that we usually give to it. But notice that all of these have that S2P1. You know, even though they're filling some D's, notice that that D level is behind. It's a 3D level. And this is why we rearrange them. If we rearrange them, that doesn't look like it's in the middle of it. You know, so rearranging kind of actually makes it look a lot easier. You know, even when we get down here and we've got some F's and some D's in there, you still finishing with 6s2, 6p1. 3 valence electrons, group 3a. And our group 4, you know, 2s2, 2p2. All of these are going to end in s2p2. S2P2. Once again, these don't have any special name, just group 14 or group 4A, and we won't refer to them as these numbers ever. I'll always kind of talk about them as the group A, or a lot of times they're called the representative elements. The group A elements are, and the reason that they're called that is because they kind of give you a good representation of all kinds of things, all the way from metals to nonmetals, and you know all the variety that you're going to see. All right, group 5, same thing. S2P3, S2P3, S2P3. Now, on the group 6, what I'd like you to do on your outline, go ahead and write in. Let's just do the first 3. I don't think we need to do more than that. But stop the video, and I want you to write in the configuration. So do the 1s2, 2s2, all that good stuff for those 3, and just put it on the side of your outline. So stop the video and do that right now. But you can see group 6 is the group 16 overall. Once again, there's no real name. It's oxygen's group. You know, it starts with oxygen, sulfur, selenium, so on. You probably should have a pretty good idea of what these are all going to end in. You may do the shortcut method if you want. Okay, our last 2 groups, when we're talking about these representative ones, are groups 7A and 8A. So we're talking about group 7A are halogens, group 8A are the noble gases. Now make sure that you know we've named basically 4 main names, or 4 new names, whatever. 1A, those were the alkali metals. Group 2A, alkaline earth. Group 7A, the halogens. And group 8A, the noble gases. Make sure you know those names. You'll be expected to know those on a test. And then, so those